We interrupt this program to bring you a special report.
I am El Nino. All other tropical storms must bow before El Nino. Yo soy El Nino. For those of you who don't habla español, El Nino is Spanish for the Nino.
No, I'm kidding.
A natural force of nature unlike any other.
El Nino means the little boy or Christ child in Spanish. El Nino was originally recognized by fishermen off the coast of South America in the 1600s, with the appearance of surprisingly warm water in the Pacific Ocean. The name was chosen based on the time of year, around December, during which these warm waters events tended to occur. El Nino and La Nina are the warm and cool phases of a recurring climate pattern across the tropical Pacific, the El Nino Southern Oscillation, or ENSO for short. The pattern can shift back and forth erratically every 2 to 7 years, and each phase triggers predictable disruptions of temperature, precipitation, and winds. These changes disrupt the large-scale air movements in the tropics, triggering a cascade of global side effects. The interaction of the atmosphere and ocean is an essential part of El Nino and La Nina events. During an El Nino, sea level pressure tends to be lower in the eastern Pacific and higher in the western Pacific, while the opposite tends to occur during La Nina. The seesaw in atmospheric pressure between the eastern and western tropical Pacific is called the Southern Oscillation. El Nino is a warming of the ocean surface or above average sea surface temperature in the central or eastern tropical Pacific Ocean. The low-level surface winds, which normally blow from east to west along the equator, instead weaken or in some cases start blowing the other direction. La Nina is a cooling of the ocean surface of below average sea surface temperature in central and eastern tropical Pacific. The normal easterly winds along the equator become even stronger. El Nino begins when the easterly winds, which normally blow from east to west in the Pacific, weaken. The major rain zone is shifted eastward towards the central Pacific, causing a prolonged dry period in Indonesia, the Philippines, and northern Australia. The Pacific Ocean is warmer along the western coast of South America. The coastal upwelling along this coast is reduced, and the nutrient-rich cold waters from the deep ocean no longer appear at the sea surface. During La Nina, conditions are reversed. The surface winds across the entire tropical Pacific are stronger than usual, and most of the tropical Pacific Ocean is cooler than average. Rainfall increases over Indonesia and decreases over the central tropical Pacific. Over Indonesia, there is more rising air motion and lower surface temperature. There is more sinking air motion over the cooler waters of the central and eastern Pacific. General impacts of El Nino are heavy rains on islands of Pacific and the west coast of South America, drought in Australia, Indonesia, and the Philippines, warmer than normal winters in the northern US and Canada, drought in Africa and India, weakening of Atlantic hurricanes, greater precipitation in southwest United States. El Nino lessens the upwelling of cold water and uplift of nutrients from the bottom of the ocean. As a result, fish either migrate to other regions or die during El Nino because they lack adequate food for growth and survival. When fish have migrated or reduced in number, other aquatic creatures, namely the seabirds and seals that feed on the fish, are also affected. As much as El Nino presents differently from one occasion to another, a common characteristic is that it creates tremendous changes in weather patterns. On occasion, this may result in extremely dry spells and drought. Indonesia, the Philippines, and Australia mostly witness much drier conditions than usual, together with droughts, forest fires, and poor crop yields. The warm Pacific air brings upon serious hurricanes, typhoons, and very cold weather in various parts of the world. In South America, thunderstorms and severe tropical cyclones are frequently associated with the drastic change in the global wind cycle circulation because of the eastward displacement of atmospheric heat. NOAA uses a 5-category alert system for tracking ENSO that is based on the combination of observed conditions, computer model forecasts, and expert scientific judgment. For El Nino, the eastern tropical Pacific Ocean has to be 0.5 degrees Celsius or more warmer than average, and wind, surface pressure, and rainfall must have begun to show changes consistent with El Nino. El Nino and La Nina can make extreme weather events more likely in certain regions. If we can predict El Nino and La Nina, we can predict a greater chance of associated extreme events. Better predictions of where and when extreme weather events are likely to happen could save the United States billions of dollars in damage costs. Predicting the life cycles and strength of El Nino and La Nina is critical for helping people plan for, avoid, and mitigate potential damages in every sector of society.